Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe and share this video to those that need it. Um, I have done so many experiments on current, electricity, potentiometer experiments with the voltmeter and the ammeter in the circuit, potentiometer experiment with just the ammeter. I have done another experiment on knife edge. In that experiment, the aim was to find the mass of the unknown using the principle of moments. Um, in today's experiment, we want to determine the weight of the ruler, as you can see on the diagram on the table here. So click in the description box below and watch all the videos. Trust me, if you watch these videos and follow them to the end, you are going to hit an A in physics. So without wasting much time, let's quickly begin. So this is the year I am working with today, June 1998. Alternative A. You are provided with a uniform meter rule, a knife edge, and a body M of mass 50 grams. Suspend the given body M by means of the thread from 1.0 cm mark of the meter rule. Balance the loaded meter rule on the knife edge as shown in the diagram above. Determine and record the value of X when the meter rule is in horizontal equilibrium. Evaluate 1 all over X. Repeat the experiment for values of M is equal to 70, 90, 110, 130, and 150 grams respectively. In each case, determine and record the corresponding value of X and 1 all over X. Tabulate your readings. Plot a graph of M on the vertical axis and 1 all over X on the horizontal axis, starting both axes from the origin 0, 0. Determine the slope S of the graph and the value of M for which X all over X, 1 all over X is equal to 0. State 2 precautions taken to ensure accurate results. Using your graph, determine the value of X for which M is 0. State 2 conditions necessary to maintain the meter rule in the experiment above in equilibrium. Using your graph, determine the value of X for which M is equal to 100 grams. So this is the procedure for the experiment. It is time for us to begin to generate our table of values. Remember, in all my experiments, I have told you the importance of table of values, and the reason why I use this question directly from here is to give us a hint on how to generate our table of values. In our table of values, we're going to have, take notes, mass. M, this is the first value of the mass, M that. They ask us to determine the record the value of X. Our table of value will contain X. They also ask us to evaluate 1 over X. Our table of value will also contain 1 all over X. And of course, these are other values of M. They say in each case, read and determine the value of X and 1 all over X. So our table of value will have mass, X, and 1 all over X respectively. This is how to go about it. Remember, I told you our table of values carries the highest marks. So first things first. So as I have told us in the previous videos, I believe we are used to the pattern with which I generate my table of values. So, as I said, this is a table of values. The first value is your M slash gram. You draw a line. The other value is your x. X also in cm, you will draw a line. Your table of values carries the highest marks. The next is x inverse, meaning cm inverse. This is your table of values. Remember I told you in the last video that anytime you have anything like x inverse, square roots, or the log of x, or the cube root of x, you have to record to 3 decimal places. Now we have to run this experiment how many times? We have to run this experiment. Let's count. This is 1, 2, 3, 4, 5, 6. We have to run the experiment 6 times. So write serial number 1, 2, 3, 4, 5, and 6. So we draw straight lines here. So we are done preparing for our table of values. The next thing is for us to know the masses that we need. The first mass, level N, this is it. This is 50 grams. That's the first mass. So write 50.00. The second mass here is 70. So 50 plus 20 will give us 70. So we write 70.00. The third mass is 90. So 50 in this experiment, the whole of this with the stand gives you 50. So this is 50 plus 20 plus another 20 will give you 90. So we record 90.00. The next one is 100. The next one is 100. So we'll slot 50. The whole of the whole of the stand with this is 50, and this is another 50. This is 100. So we have 110. This is 10 grams. This is 10 grams. So this is 110. So record 110.00. The last one is 130. So 110 plus 20 will give us 130. So record 130.00. The next one is 150. So we need 3 of this. This is 150. You slot it here, and then it will enter. So this is 150. So we record 150.00. So these are the masses we need for this particular experiment. So we put them very closely, and then we start the experiment. Remember, this is the principle of movement. It states that for a body to balance horizontally, the anti-clockwise movement, which is on my left-hand side, must be equal to what? The clockwise movement from my right-hand side. Moment simply means force times perpendicular distance. In this case, this mass times the distance x is the moment. That's why you see mx here. Is equal to what? Wy. So the weight of the ruler is at the center of the ruler, the center of gravity, CG. The center of gravity is the point where the entire mass and the entire weight of the body is concentrated. So we are going to apply or verify the principle of moment throughout the experiment. This is the diagram for the experiment. So let us begin. I'm going to take away this and start the experiment straight away. So I'm going to hang this on this thread. Those guys asked us to place this at the 1 cm mark. So we are going to start with 50. So we don't need to even put this one here. What we know is that our 50, the whole of this is our 50. So we are going to place this here at 100 cm, at 1 cm mark. This is the point we are going to place this thing throughout. At 1 cm mark throughout this experiment. This is it. And so we're going to balance it on the knife edge there. So the next line of action is for us to balance this. In balancing this, it takes patience for us to do that. So I'm trying to balance it now. If you are not patient enough, you won't do this. And again, the masses must not be touching the table. That is one precaution. So it's a report. I ensure the masses were not touching the table. So I'm taking the book away. You see, they are not touching. So at this point, the ruler is balanced. I'll be pausing this video intermittently to fast forward the balancing process. So it is balanced at 38.8. I will take it closer so that you see it very well. Good. You can see that very well. That's the balance point. So we're going to say 38.8 minus 1. 38.8 minus 1 will give us our x. And that is the value of x. 38.8 minus 1 will give us 37. So record 37.80. That is what we recorded. The next value is 70. So this is already 50. So we are going to add this to this. So we slot it here. Good. And then we take another new balance point. So we adjust it until so I told you I'll be pausing this video intermittently because of the balance point. This experiment takes patience, endurance, and calmness before you can get your accurate results. Now, before I continue, these are the precautions. I avoided error due to parallax when taking reading on the meter rule. You don't bend, you don't stand this way to take a reading. You don't stand this way. You stand and you face straight. You face straight. This is a new balance point. So I avoided error due to parallax when taking reading on the meter rule. So I'm going to take the camera very close so that you see it, then we'll take our reading. Number 2, you say I avoided air interference by offing the fans or by closing all the windows. So these are the 2 primary precautions you take in this experiment. So this is a new balance point when our weight from the left hand side was 70 grams, and this is a new balance point. So what we're going to say is this is exactly 35.9. It balances at 35.9. So 35.9 minus 1 will give us the new value of our x. So we say that 35.9 minus 1, we're going to have 34.9. So we record here, record 34.90. Don't just write 9 but 90. You can see that from the calculator. Lovely. So the next one is 90. So 50 plus 70 plus 20 will give you 90. So we slot this again, and then we find a new balance point. Don't forget, I told you I'll be posting this video for the balance point. But if we are lucky that the balance this early, there will be no harm. We are lucky this time. That is the balance. So the balance point is 32. No, the balance point is exactly 33. Let me take the camera close. The balance point right now is 33. So I will take the camera close and you'll see it, and then we'll proceed. So this is the balance point, 33. So 33.00 minus 1 will give you 32.00. That is it. So 33 minus 1 will give us 32. So you record 32.00. The next one is 110. So this is 90. We're going to remove this, remove the 220, remove the other 20, and then add 50. I told you the whole of this is 50 grams, so we're going to add 50 to this, and that will be a 100. It's a 100. 110. This is 10 grams. So we add 10 to it, and that is our 10 grams. And then we balance it again horizontally. You must ensure that the masses will not be touching the table. It is balanced again. Let me just check it. Wow, that's lovely. It is balanced. It is balanced. So the new balance point now is a 30.9. 30.9 is a 0.9 is a new balance point. Very close. Let's watch it closely. That's it. You see that? 30.9 minus 1 will give us the value of x. From this point to this point is our x. And so we say 30.9 minus 1. And that will give us 29. 29.9. So we record 29.90, not 29.9. Lovely. The next one is 130. So we already have 110 here. So we just need to add this 20 to that. And then we'll get 120, so we add it here. And then we try to balance it again. Mind you, there's no mass on the other side. This experiment is balanced by the weight of the ruler at the center of gravity of the ruler. So this is where the center of gravity is. So we try to balance this again. So the ruler is balanced perfectly horizontally right now. At this point, the anti-clockwise moment is equal to the clockwise moment. So, what is the balance point? The balance point is 28.9. Let me take it very close. 28.9 is the balance point. Yeah. 28.9 is the balance point. So, sorry. Yeah, 28.9 is the balance point. So 28.9 minus 1 will give us the new value of x. So we said that 28.9 minus 1, we have 27. We have 27.90. The last value is 150. So we are going to remove this, and then we are left with 100 plus 50. That will give us 150. So this is 150 right now. The whole of this is 150. So we try to balance it again. This is our last value. Let me sit down a little bit. I told you need to be patient. You need to be calm and gentle. These are the soft skills, the principle of movement want to cultivate in every student. Yeah, it is balanced, and it balanced at 27. It balanced at 27. Yes, exactly on 27. So if I take the camera very close, you will see that. So 27 minus 1 will give us x, which is the final value in this experiment. So set 27 minus 1, that will give us 26. This time 26.00. So what do you observe? We are through the experiments. You see how these experiments are very, very simple. These are table of values. You observe that we have the values of m are increasing down while the values of x are decreasing down. If we are going to plot a graph of m against x or x against m, we are going to have a graph that will look like this. 0, 0, a graph of m in gram, x in cm, or x against m. We're going to have a graph of this nature. We call it a negative graph. Now, do you know why we always have inverse of variables in an experiment? These are the composite table. We have inverse of this to convert our graphs into a graph that looks like this. Maybe a graph of M in grams against X inverse slash CM inverse. Such graphs will look like this: 0, 0. One may pass through the origin, another may pass like this. So have something like this, something like this, something like this. So if we are going to find the value of X inverse, which we're going to record to 3 decimal places, and the graph of M against X inverse will give us any of these, either graph 1 or graph 2 or graph 3. Lovely. So X inverse simply means 1 all over everything here. We record it there. So let's start with the first value. We have 1 divided by 37.8. 1 divided by we have 1 divided by 37.8. That will give us 0.026. We record everything to 3 decimal places. 1 divided by 3 points by 34.9. We have 0.028. Yes, and so we are done with the table of values. So as I was saying, right now what we have right now is an increase trend. Originally we have increase decrease with a graph of this nature. So the graph of M against this or this against M will give us something like this. So now that we have increase trend, now we're going to have any of this graph. Watch out for the second video on this particular experiment. I have predicted graph 1 or graph 2 or graph 3. Graph 1 with an intercept on the vertical axis. Graph 2, a graph passing through the origin with no intercept. Y is equals to mx. That is the equation for graph 2. Graph 1 and graph 3, the equation is y is equals to mx plus negative c. So any of graph 1, 2, 3 are the graph we are going to expect in the second video, where I'll be plotting the graph and doing all the deduction. Thank you for staying over there to watch with me on Physics with Ben. Don't forget to subscribe and share this video to those that need it. Bye bye. God bless you.